morning students. JEE Mains 2020 in 7th Jan shift 1 there is a question was asking from thermodynamics, that is a Carnot engine between two reservoirs of temperature 900 Kelvin and 300 Kelvin. The engine performs 1200 joules of work per cycle. The heat energy in joule delivered by the engine to the low temperature reservoir in a cycle. So this is the numerical type of question. Now we have to solve it. Let's see how we can solve it. Solution. At first, the given data, the temperature differences are 900 Kelvin and 300 Kelvin. So here T1 is equal 900 K and T2 is equal to 300 K. And the engine performs 1200 joules of work per cycle. So here the work done W is equal, whereas Carnot engine W is equal Q1 minus Q2. It is equal 1200 joules per second per cycle, 1200 joules. So here we have to find out the heat energy delivered by the engine to the low temperature reservoir. So the low temperature reservoir, you have to find out the Q2 value. The heat energy delivered by the reservoir at low temperature, it is Q2. Q2 is how much? So let's find out the efficiency of the Carnot engine. Eta is equal to 1 minus T2 by T1. Just to simplify it, eta it is equal 1 minus T2 stands for where it is high temperature, so low temperature, so that is 300 K by, whereas T1 900 K. So here it is equal 1 minus 1 by 3. It is equal 2 by 3. So eta is equal 2 by 3. So keep it, and we have to find where Q1. So whereas W is equal Q1 minus Q2, just we have to find out Q2 is equal Q1 minus W. Q1 minus W. Already W value was given to us, that is 1200 joules, but to Q1, how we can derive it? So Q1 is equal, where it is from definition, the efficiency of the Carnot engine, it is work done upon heat energy supplied to the system. Heat energy supplied to the system, where here Q1 is equal W by eta, where W already we know that is 1200 joules by eta is equal, it is 2 by 3. Since we can derive, it is 3 into 1200 by 2. So here it is equal 1800 joules, that is Q1. So from the equation where Q2 is equal Q1 minus W. So Q1 is equal 1800 joules. Q1 is equal 1800 joules minus W is equal 1200 joules, whereas 600 joule. So the heat energy delivered by the engine at low reservoir, it is equal 600 joule. This is the answer. January shift to JEE Mains 2020 from current electricity. The question it is, in a building there are 15 bulbs of 45 watts, 15 bulbs of 100 watts, 15 small fans of 10 watts, of 2 heaters of 1 kilowatt. The voltage of electric main is 220 volts. The minimum fuse capacity of the building will be approximately. So here options are 10 ampere, 20 ampere, 25 ampere and 15 ampere. Let's find the solution. Here minimum fuse capacity of the current I is equal total power consumption by voltage supplied. Voltage supplied. So whereas voltage supplied will be given, voltage supplied is equal to 220 volts. So what is the total power consumption? So power consumption will be find out by number of appliances and to the usage of wattage. So then there are so many appliances are there, 15 bulbs and different wattage, and 15 small fans of 10 wattage and 2 heaters of 1 kilowatt. So the total power consumption will be found out by the sum of all the appliances usaging of wattage. So therefore total power consumption is equal to, here first 15 into 45 675, 15 into 100 1500, 15 into 10 150, 2 into 1000 2000. So therefore the total power consumption, it is equal 4325 watts. So here what we have to find out, so the minimum fuse capacity of the current I is equal to total power consumption by 4325 wattage by voltage supplied, it is 220, it is equal to 19.66 ampere. It is approximately nearer to the 20 amperes. Therefore the option B is right answer.